2.2, properties of quadratic functions in standard form. Yesterday at the end of the lesson, we learned how to find the vertex of each function of a function. So I want you to find the coordinate of the vertex of each of these two functions. I want you to try to find it on your own. Okay, I'm obviously not going to wait. In order to find the vertex of the function, we take the opposite of the number inside parentheses. So that's a minus 2, so it's going to be a positive 2. And then keep this the same, positive 3. Remember, opposite h, same k. This one would be negative 1, negative 4. This shows that parabolas are symmetric curves. The axis of symmetry is the line through the vertex of a parabola that divides the parabola into two congruent halves. So if we're looking at this parabola, we have a quadratic function, a times x minus h squared plus k. The axis of symmetry is going to be whatever our h is, or the first number in our ordered pair. If we look at this line, this is our axis of symmetry. It's saying that if I flipped this over this line, fold it in half like it was a piece of bread or a piece of paper. If I fold it in half across this line, this piece would end up exactly the same as where this half is. So it would perfectly mirror it. Example 1, identifying the axis of symmetry. Rewrite the function to find the value of h. So here I have f of x equals negative 1/2 times x plus 5 squared minus h. In order to rewrite this function, it would just be negative 1/2 x minus negative 5, because that's the only way I could get that to turn into a plus, and my original equation is x minus h squared minus 8. Axis of symmetry is just going to be negative 5. So AOS equals negative 5. And you're done. So whatever the h is. Identify the axis of symmetry for the graph of x minus 3 squared plus 1. AOS is 3. Pretty easy, right? Another useful form of writing quadratic functions is the standard form. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. Coefficients a, b, and c can show properties of the graph of the function. By the way, a cannot be equal to 0, because 0 times x squared would get rid of this entire piece, and you would just be left with a linear function, bx plus c. It can only be quadratic if it has an x squared. Okay, in our standard form, a is the same as in vertex form. It indicates whether we have a reflection and or a vertical stretch or compression has been applied. Remember, if it's a reflection, then it's going to be negative. If it's a vertical stretch, it's going to be a number greater than 1. And if it's a vertical compression, it's going to be a number between 0 and 1, either a decimal or a fraction. B, if we solve for h, well, b is equal to negative 2 times a times h. So solving for h gives us h equals b over negative 2a. So to solve for h, I would just divide both sides by negative 2a. On this side, that would all cancel out. I'd just be left with h, and it's b over negative 2a. You can also think of that as just negative b over 2a, because the negative goes out in front of the whole thing. Therefore, our axis of symmetry for x equals h for quadratic function in standard form is x equals negative b over 2a. So if I need to find the AOS and I'm given this form, or the standard form, it's just negative b over 2a. The c is a times h squared plus k. Notice that the value of c is the same value given by the vertex form of f when x equals 0. So c is our y-intercept. If I plugged a 0 in for x, it would be a times 0 minus h, which is just negative h squared, would make it positive. So it's ah squared plus k. So when x is 0, c is your y-intercept. Properties of a parabola. For f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers and a is not equal to 0, the parabola has these properties. If the number in front of the x squared, or the a, is greater than 0 or a positive number, it opens upward. It opens downward if a is less than 0. The axis of symmetry is our vertical line, x equals negative b over 2a. The vertex is if we plug our axis of symmetry into the equation, or into the function, it will give us the y value of the vertex. So the x value is just your axis of symmetry, and your y value is if you plug that axis of symmetry in. And then our y-intercept is c. So I can use these details to graph any quadratic function. Remember, when a is positive, the parabola is happy. It's like a smiley face. So when things are positive, you're smiling. When the a is negative, the parabola is sad, like a frowny face. So when it's negative, it's sad. Just an easy way to remember what our a does to the function. Okay, consider this function, f of x equals 2x squared minus 4x plus 5. Determine whether the graph opens upward or downward. So that's our first part. So in order to tell whether it opens upward or downward, we look at the number in front of the x squared. That's our a. Is that positive or negative? Since it's positive, it opens upward. So I know that now I'm going to be in this shape. Then find the axis of symmetry. Remember, the formula for that is negative b over 2a. In this case, this is our a, this is b, this is c. Negative of a negative 4 over 2 times a. Negative of a negative 4 is a positive 4. 2 times 2 is 4. So our axis of symmetry is 1. Then find the vertex. So to find the vertex, we take this axis of symmetry we just found, the 1, and we plug it into the formula. So to find the vertex, I'm replacing every x value with a 1. So this would be f of 1 equals, started with f, right? Yep. F of 1 equals 2 times 1 squared minus 4 times 1 plus 5. 1 squared is 1, so you do 2 times 1 minus 4 times 1, so minus 4 plus 5. 2 minus 4 is negative 2, plus 5 is 3, so that's the y value of my vertex. Now I have to put my axis of symmetry and my y value together to get the whole vertex. 1, 3. Without that 1, it doesn't count. You get half credit. Lastly, to find the y-intercept, I plug 0 in for x, f of 0. That gives me 2 times 0, which is 0, minus 4 times 0, which is 0, plus 5. Literally every time, it's going to be whatever this number is. That's our y-intercept. Y-intercept is always at 0, and this one is at 5. Then we can graph the function. Now I can graph this function just using the information I already have. I found that my vertex was at 1, 3. So I go to the right 1 and up 3. Make a dot. Then my y-intercept is at 0, 5. It's going to be facing upward, so I know that I can draw from down to here. Then to do my other side, I had to go left 1 and up 3 to get from my vertex up to my y-intercept. So I go the opposite direction, right 1 and up 3, because this is our axis of symmetry as well, which means that whatever happens to the left happens to the right. And that's my graph. Okay, we're going to stop there, and I will give you some problems on this, finding axis of symmetry and things of that nature.